In today's lesson, we are going to be looking at representing data. So, graphs can make data easier to understand for the average person. It is important to have a general understanding of the different ways to present data. So that's what we're going to be looking at. We're just going to be looking at the different ways that we can visualize or present the data that we might collect. Now, most of the data will either include one or two variables. So for a one variable data set, basically you're saying you know one attribute or one piece of data about each subject. So for example, if we're looking at a group of people, we say for a one variable data set, we know their height. For a two variable data set, we know two attributes about each subject or each person or whatever the case may be. So again, if we're looking at a group of people, we know their height and their weight. That would be an example of a two variable data set. And usually when we have two variables, we're trying to look for a connection or a correlation between those two attributes. Is there a connection between or a relationship between the height and the weight of a person? So to present one variable data, we generally use histograms, bar graphs, broken line graphs, and circle graphs. When we're looking at two variable data or trying to compare two values, we look, or to see if there's a relationship, we use scatter plots. So we're just going to be looking at the different types that we just mentioned and seeing what are some of the characteristics of each type. So the first one is looking at a histogram. So this is a histogram looking at the distribution of NHL or NFL player retirement age. So we have the age on the bottom and we have the frequency along the side. So in histograms, the data is grouped into intervals. So in this case, it may look like we're only looking at bar graphs for 1 year. This is technically intervals. So anyone between the ages of, say, 25 and 26 go in one bar, 27 to 28, and so on. So even though it might look like a bar graph, the numbers are actually representing intervals. Because if you're looking at someone's age, they could be anywhere between these values. They're not going to be specific values, right? So you could have someone that's 25 years and 2 days, right? They would still be grouped into a specific interval. 25 years and 364 days. They're still going to be grouped within the same interval. So part of that is why the graphs touch to show no gaps in the data, because we're looking at intervals. So any value between the intervals gets included into a bar. Generally speaking, you want to have about 5 to 10 bars if possible. If you have more than that, then you tend to, or your data tends to be too spread out, or it doesn't show the distribution well enough. If you have too few, again, it does the same thing. It clumps the data into too few bars, so again, it doesn't show how it's spread out. In this case, obviously, it's more than 10 bars, but this is just a specific example where it does help to have the individual age ranges, because we do have enough data for it to fit nicely and we can see the spread. A bar graph is again similar to a histogram, except now there is gaps in between. And generally speaking, when we're looking at bar graphs, the data is grouped into independent categories. So in the histogram, the categories were all kind of the same. They were ages. It was a measure of time. So they were all relatively the same. It was just different intervals that we were looking at. Here, we're looking at different languages. So the languages don't blend together. There's not a spread between Mandarin and Spanish. It's just Mandarin, just Spanish, just English, and so on. So again, bar graphs are split up into the individual or independent categories. There's an equal space between the bars, again, just to help show or to keep everything relative in size. If there's a bigger space, it may give an appearance of being larger or smaller. It may just kind of skew the data a little bit. But again, equal spaces between the bars. There are spaces because the categories are separate from each other. And the importance is to show how categories compare to each other. So in this example here, where we're looking at the languages spoken and the number of speakers in the millions, we're looking at a comparison between the languages, right? So we can see clearly in the bar graph, Mandarin is the one of the most spoken or the highest spoken language based on the data, then Spanish, then English, then Hindu and Urdu, and so on. So we're seeing a comparison between these different categories, and it's an easy way to visually see that. A circle graph or a pie graph, again, the data is grouped into independent categories, but it could be continuous. And again, continuous data, we looked a little bit at the definitions in the previous investigation, but continuous data just basically means data where there's an infinite range of values. So usually things that you measure. It could also be independent categories or discrete data, as we might call it. So for example, looking at pumpkin pie or the different types of pie, right? That data is not continuous, that data is categories. Looking at pumpkin pie, looking at chocolate pecan, apple, other, and just regular pecan, right? Those are independent categories. The importance of a circle graph or a pie graph is to show the comparison with each categories and the percent of everything. So it's showing the percent of the population or of the group surveyed, as well as a comparison between other categories. So in the example of our favorite pies in a pie graph, we can see that pumpkin pie is the most favorite type of pie because it has the largest percentage. We could also say 39% of our sample group or of the school or of the city, whatever we surveyed, like pumpkin pie. Looking at scatter plots, again, scatter plots, this is where we are looking at two variable data. Generally, the two variables, one would be the independent and one would be the dependent. Independent means that it's not affected. We're looking to see if it causes an effect in the other variable. Right? Independent, it doesn't rely on anything. It's not affected by anything. Dependent, you are relying on something else or you are affected by something else. So generally when we look at two variables, usually we have an indicator of what we think is causing the effect and what is the effect. Right? In some cases we may not, but when we graph it, we're looking to see, when we're graphing it and when we look for a relationship, we're looking to see if the x variable affects the y variable. Right? Again, the independent is on the x, the dependent is on the y. And it's used to show a relationship between two sets of data. Right? So again, we talked about at the beginning of the lesson, scatter plots are the only ones that we use, or only ones that we're going to look at, that focus on showing a relationship between two sets of data. So in this scatter plot here, we look at the drownings at the beach in summers specifically since '94, and we look at also the total ice cream sold at a beach shop. So by looking at these two variables, the ice cream sold at a beach shop is on the x or the horizontal, so that's the independent, and the number of drownings is on the dependent. So this graph is looking to show us, or is going to show us, whether or not there's a relationship between the ice cream sold and the number of drownings. Based on the data and based on what we can see here, it would look like there is a trend or there is a relationship. And that relationship would be that as the number of ice cream or as the amount of ice cream sold increases, so do the number of drownings. So you might conclude that ice cream being, the more ice cream you sell, the more drownings that there will be. So you could say that ice cream causes drownings. Now, we'll look later at why this statement is probably not true. But when we're looking at the graph, that's what the relationship is showing us. A broken line graph. So in the broken line graph, the data is continuous. So this means there's an infinite range of possible values. And usually it's used to show the general trend of the data. So here we're looking at the unemployment rate at different time periods. And again, the rate would be continuous, and even time would be continuous because there's an infinite number of possible decimal places in the percent, as well as when we're looking at time, there's an infinite number of time points or possible values, depending on how accurate you wish to measure something. So again, looking at our example, it's showing how the unemployment rate changes over the different time periods, or over the different, I would want to say the different years measured in March. I would not expect it to be days, because the unemployment rate probably wouldn't change that drastically in individual days. So it's most likely looking at over different years or through the years. And again, it does show us nicely the trend of the unemployment rate. So again, all we're really looking at is just the different representations of data that we might see, whether you are collecting data and putting it into a specific form or a specific representation, or you're finding these representations and are trying to read them. Hopefully now you have a little bit better understanding of what information would be included in the graph or the representation, as well as when we would want to use it, based on some of the characteristics. But again, the main thing is just understanding we have different types of possible representations, and each type has its kind of different characteristics.